Let's look at an example for writing formulas for ionic compounds for polyatomic ions. Polyatomic ions are ions made up of two or more atoms that are covalently bonded together. And there are a list of common polyatomic ions on the back of your periodic table. The polyatomic ion I want to look at first is the sulfate ion, which is at the bottom, towards the bottom of your data sheet. The formula for the sulfate ion is SO4 with a charge of -2. SO4 with a charge of -2. So the sulfate ion is not the sulfide ion, which would just be sulfur, an atom that has gained 2 electrons to have a charge of -2. The sulfate ion is different. The sulfate ion is one sulfur atom bonded to 1, 2, 3, 4 oxygen atoms, and the complex as a whole has the charge of -2. It's important to realize that changing the formula of the ion changes the ion. So we cannot change this formula. We cannot change any aspect of this ion, otherwise we change the ion. So if we are trying to make an ionic compound that involves the sulfate ion, like perhaps aluminum sulfate, aluminum is an element on the periodic table in group 13, so it forms ions with a charge of +3, and the sulfate ion, as we said, forms it is an ion that has a charge of -2. So we're going to use the green Legos with 3 circles to represent the charge of +3, and pink Legos with 2 circles to represent the charge of -2. As always, the positive and negative charges must cancel out so that the total charge is 0. Same with our other examples. So let's look at how we can make the charges cancel out. So here I have a charge of +3, a charge of -2, and if I have one of each kind of ion, I can see that I have more total positive charge than I have total negative charge. So I need to bring in more total negative charge by bringing in another sulfate ion. When I do that, I now have too much negative charge. I don't have enough positive charge, so I need to bring in positive charge in the form of another aluminum ion. When I do that, I have too much positive charge, not enough negative charge, so I bring in a more negative charge from bringing in another sulfate ion. When I have 2 aluminum ions and 3 sulfate ions, then my charges balance out. 2 aluminum ions and 1, 2, 3 sulfate ions, the charges balance out. Let's just check to make sure our positives and negatives cancel out. My total positive charge, I have 2 ions with a charge of +3 each, so my total positive charge is 6. And I have 3 ions with a -2 charge each. 3 times -2 is -6. Positive and -6 balance out, so my overall charge is 0. So how do I go about writing the formula for this substance? Well, if I just follow the procedure we've done before, where I just write a 3 as a subscript next to the ion, it looks like I actually have 43 oxygens. That's confusing, so we can't just put a 3 subscript next to the SO4, the sulfate ion. So what we do instead is we use parentheses to set aside the polyatomic ion, the sulfate ion. We write the sulfate ion in parentheses, and we put our 3 outside the parentheses to make it clear that there are 3 of this entire ion. So there are 2 aluminum ions and 3 sulfate ions, and this is the correct way to write the formula for aluminum sulfate. Please notice that it is not okay to change the subscript on the sulfate ion, because when you change the formula, you change the ion. It's also not okay to put the aluminum in parentheses. When you have a monatomic ion, an ion made up of just one atom, we never need to use parentheses. It's okay to just write the subscript next to the ion, as we've done for aluminum here.